I'm Omer Aviv, creator and CTO of Ozcode, and today we're excited to have Simon Timms, Microsoft MVP, present to us on debugging Azure Functions with the Ozcode Production Debugger. With that, I'll let Simon kick it away.
Mute that there. Hi, everybody. Thank you very much for coming out and joining us today. I'm going to take us through kind of an introduction to Azure Functions today, and then we'll take a look at how we can use the production debugger to help out with Azure Functions. So I'm hoping this little icon will disappear. There we go. So we're going to start today just a quick introduction to Azure Functions, what they are, how you can use them, what their history is, all of that stuff. We'll touch very briefly on durable functions, which can be used for orchestration. And then we'll drop into some code and we'll see exactly what happens with the production debugger. So to start with, this session is sponsored by my good friends over at Ozcode, who have been building a variety of interesting products for .NET developers for, what, about 6 years now? So their initial product offering that I was familiar with was a Visual Studio plugin that allows you to improve your debugging process. And now they are working on applying the same sort of technology that was developed there, so the ability to look ahead and to annotate your code during debugging, pulling that out and putting it into a web application that can be used to do production debugging. So this is just some quick information about Ozcode as a company. It's used by over 1,000 developers and enterprises, used by more than 5,000 developers in the general world. I've been using it for 3 or 4 years, and it's definitely made my workflows a lot easier. Definitely improved my life in many, many ways. So the production debugger is sort of the new entrant into the Ozcode family. It's pretty exciting, and I think that you're going to be interested to see what it's like, especially if you have any sort of code in production at all, which hopefully everybody does at this point. So the idea here is that no matter how well you test your code ahead of time, there are bound to be some things that sneak through and end up being problems in production. You can put in place unit tests, integration tests, all manner of other tests in your development environment, but production tends to be a completely different beast. And sometimes that's just because users do things in your application that you could not in your wildest dreams have imagined that they would do, and that it goes down code paths that you didn't expect, or they do things that are very strange. Sometimes it's a question of volume of data. Very few websites have the ability to run their testing environments at the same scale that they run their production environments. That tends to be fairly cost prohibitive to do, and being able to simulate tens of thousands of simultaneous users is quite tricky. So oftentimes you'll have problems that appear in production that you just didn't have the ability to reproduce in testing environment. And then it could be that application APIs are slightly different in production, that you're doing slightly different things with third-party vendors. But problems do exist in production that don't exist in your development environment. So typically the workflow that people have taken to deal with this is that you'll see some sort of alert that something is wrong in your production environment. This could be something that comes in through your log monitoring tools. It could be something that somebody calls you up and tells you that your application is down. It could be that you notice a change in the volume of data flowing through your application. So you normally expect to see on a Monday morning 500 users online, and all of a sudden you're only seeing 12 users online. That could be indicative of a problem. So once you've noticed that there's a problem, you drop down to whatever your logging tool is, and you take a look at the logs to see if you can find anything that looks out of the ordinary. Now, I don't know how people are gathering logs on this call, but I typically use some sort of a distributed logging tool, so something like Sumo Logic or application insights, something like that, that gathers logs from a wide variety of different services that make up my application and follows them into one place. Even having that, it tends to be that a lot of logs get produced. On a relatively large system, it wouldn't be unusual to gather 10, 20, 30 gigabytes of logs every day. So sifting through those can be quite tricky. And it always seems to work out that once you've figured out what the problem is, you don't actually have the right logging in place for it. It's just like that one thing that you forgot to log, or that one area of the code base that you didn't think needed to be logged, that ends up being problematic for you. So in order to fix the problem, you end up adding additional logging to try and find what the root cause of your problem is. So you add your additional logging, and then of course you need to redeploy your application to get that logging to show up. In a modern DevOps-driven world, redeploying your application shouldn't be a huge deal. It should be a couple of minutes to redeploy your application. But I know we don't all live in that fantastic DevOps future. So sometimes redeploying your application can be pretty arduous, especially if you need to go through any sort of security approvals or anything like that to get your application out there. So once you have the new logging entries in there, you can dig a little bit deeper and hopefully get a better idea of what it is that's causing that problem. This tends to be a little bit of a cycle that you might have to do several redeploys to add more and more logging, pulling up different variables each time to try and get an idea of what it is that's going wrong. Once you have a pretty good idea of what's going wrong, then you can move over to your local environment and try and reproduce that in your local environment. This, again, can be pretty tricky to do, but it tends to take a little bit of effort to get it in exactly the same situation that production is in. If you have a lot of different services that are chatting back and forth, setting up your local environment could be pretty difficult. And then eventually you end up with a fix that you deploy out. The production debugger aims to kind of shortcut this process so that you get your bug alert the same way that you would before. But now instead of dropping into your logging application, you can drop into the Ozcode Production Debugger and take a look at what's actually happening in your code base. So we'll take a better look at this in a little while, but the idea here is that the Ozcode Debugger allows you to short circuit this long-winded debugging process and lets you see call stacks and local variables and all those wonderful things inside of your application just in a web browser as if you were running inside of Visual Studio. And then you can kind of move back and forth to find what the problem is and go directly to being able to fix it and deploy a fix. All right, so we wanted to talk today about serverless computing. So this is a relatively new idea. Probably the first entrant of any report in this is AWS Lambda, which has been around for perhaps a decade now. But all the major cloud providers have similar services that you can tie into. So AWS has Lambda, Azure has Azure Functions, and Google Cloud has something that I think is called Cloud Functions. I've not ever used that, but they all provide basically the same sort of capability inside of the cloud. So the idea here is that you want to deploy something small that doesn't cost you a lot of money. So typically the billing on these is per execution. So if your application is heavily used, it scales up transparently and just bills you for every execution. If your application ends up being quite small, then you get billed again per execution, so your bill is very low. So this is a fantastic way of deploying your application if you are doing perhaps a startup and you're not sure what your load is going to be. Instead of having to allocate an entire server to run your application, which could be costly, you can allocate a single function which only gets billed when it gets executed. So this means that you're able to run very large websites on very little money. So there's a great case study for this. I'm not sure if people are familiar with the website Have I Been Pwned, but this is a website where you can go and enter your email address, and it will tell you if your email address has ever been found in password dumps that are available on the internet. So this will give you a hint of like, you need to go and change your password. But this entire website runs on Azure Functions and on other serverless backend technologies. Troy Hunt, the developer of this, has done some really good blogs about what it costs him to run this website. So he processes, I think he was on the order of 20 million requests a month on this website. And his costs to run this kind of run to about $30 a month to run what is an absolutely huge website. So you can scale very nicely and for very little money using functions. Of course, there are like a million different ways to deploy your code onto Azure. If you have a website that you want to get up onto Azure, or an API that you want to get up onto Azure, you could use Service Fabric, you could use virtual machines, you could use an Azure Kubernetes cluster, you could use an Azure Container Instance, you could use app services, you could use any number of different things. And one of the problems with really all of these cloud providers is that you're just spoiled for choice. You have to make a lot of decisions about what it is that you're going to deploy. Serverless is just kind of another tool in your toolbox here, so it isn't necessarily the right answer for everything, but it's a pretty good answer for a large number of scenarios. So places where it isn't necessarily a great fit are processes that are really long running. So if you're encoding a video, functions probably not the right choice for you because they have some limits around how long you can run them for, and they tend to get a little bit costly if you're kind of running them continuously. That's one place where they're not fantastic. And then traditionally, anything where you need to do kind of complex business processes, that's not been a great place for functions because you want to make it sort of as short and easy as possible to run these functions. All right, so there are some cost advantages to using serverless. If you're using a traditional deployment model, you're probably used to seeing something like this. You have some spiky load throughout the week. Monday has pretty high load, Tuesday less so, Wednesday sort of in the middle, and so forth. But in order to set up your application, you pretty much need to provision for the maximum possible load that you have. So Monday, you're using 100% of your resources, but Tuesday, you're only using maybe 30% of your resources, and so forth for the rest of the week. So you end up spending a lot of money on hardware that you're not using. And this is, of course, an even bigger problem for businesses which are cyclical throughout the year. So if you think of something like a university, the registration system, come June or July, the registration system is spectacularly busy because everybody is trying to register simultaneously. During the rest of the year, that system is almost unused. So this is a very spiky sort of load, and serverless really makes this a lot better because it allows you to sort of scale up and scale down your application dynamically, transparently even to you based on this load. So you don't even have to go in and fiddle with any tuning knobs. It will just do this for you. So I'm going to run you through kind of the 50-cent tour of what Azure Functions is, how it works, all of that good stuff. So like I mentioned before, Azure Functions is a serverless compute service. It is on demand. So anytime you ask for resources, it will allocate those dynamically for you. It's able to scale up and scale down pretty quickly. I'm kind of a little bit involved in a project where we're looking to scale up from 0 requests to 200,000 requests, probably 200,000 requests a minute. I guess it would be 0 to 200,000 users over the course of about 5 minutes. So we are using Azure Functions to do that scale up and scale down. So we are pre-provisioning a bunch of servers for that. But because we're not sure exactly what the load is going to be like, we're going to have a level on top of this, which is just dynamically scaling up and down. Functions are pretty low cost. You can run hundreds of functions for a penny. And of course, these are highly scalable. So you can go from that 0 to 200,000 requests pretty quickly and easily. Azure Functions are event-driven. So there's a bunch of different ways of kicking off these functions. And they can be started using kind of HTTP triggers, or they can respond to events in Azure. So things like stuff coming onto the service bus, or things being written into blob storage. The pricing for Azure Functions is pretty cheap. So they are built by this kind of made up unit called a gigabyte second, which is sort of a funny thing to think of. But you're billed basically by the amount of memory that your application uses and the time in which it takes to execute. So that means that you really should try and optimize for functions that use as little memory as possible and run as quickly as possible if you're looking to make your code cheap to run. I mean, those are good things to optimize for anyway, but here it will actually save you a bunch of money if you can optimize for those things. So this makes things like .NET Core 3.1, which is a lot faster than previous versions of .NET Core, really advantageous for running Azure Functions. You're also billed by the number of executions. So every month you get 1 million executions for free, and then after that it costs you about 25, 26 cents per million executions. So if you're running 10 million executions through every month, it's going to cost you 9 times 25 cents a month to run, which is not too bad. All right. So Azure Functions, it's been around for a little while now. They're kind of revving it and versioning it up. Azure Functions version 1 is based on the older full framework version of .NET. So it runs C#, it runs F#, and it runs JavaScript, but unfortunately JavaScript on Node 6, which is a little bit antiquated. Fortunately, .NET or Azure Functions version 2 is out now. So it supports, again, .NET Core languages. So it's going to run C#, F#. It also supports JavaScript, Java, and both PowerShell and Python as well. I'm not sure if those are both still in preview, but they're all pretty exciting. So personally, I tend to write my functions in C# or F#. Those are probably the fastest of the languages that you see here. And they're pretty good for building all of this stuff. Like I mentioned, there are a bunch of different ways to trigger a function for it to run. So probably the more common one, and the one we'll be taking a closer look at today, is using HTTP trigger. So this basically means that you can just stand up an endpoint on an HTTP server somewhere and call it. So you can call it with your typical get, post, put, all of those sorts of verbs. And in this way, it's almost like writing a web API application, except that it's hosted entirely on Azure Functions. You can trigger it using a queue. So any sort of queuing technology will work here that exists in Azure. Typically, what I'm talking about in this one here is storage queues. So these are queues that allow you to just drop messages in there, and anytime a message is noticed by Azure Functions, it will spin up and process that message. You can also trigger on blobs. So if you have some blob storage and you drop files in there, every time the file is finished writing, then a trigger will be fired, and the Azure function can pick that trigger up and process the blob. So this is really good for something like resizing images. If you have a place on your application where you upload an image and then you want to resize it or do some processing of it, you can use a blob trigger, and it will notice anytime an image is there, get the image, resize it, put it back in blob storage, and away you go. You can use Event Grid as a source of information. So Event Grid is the sort of latest messaging technology on Azure, and it allows you to tie into actual Azure infrastructure changes. So if you wanted to tie into something like every time somebody provisions a new storage account, then fire this function. So it's really good for infrastructure things. If you have an infrastructure group that's interested in controlling costs within Azure, then Azure Functions can tie into all of the changes inside of Azure and fire things off with that. And then you can, of course, also put your own information into Event Grid and build it out using that. You can schedule anything to happen with an Azure function. So this uses sort of the same idea that has existed for a while using the Azure scheduler. So you can say things like, I want this function to run every Thursday night at 2 a.m. And of course, you can provide a complicated cron entry for that, allowing you to build up really complicated schedules. You can fire from the Cosmos DB change feed. So anytime a record is added to Cosmos DB or anytime a record is changed in Cosmos DB, you can fire a function. So this allows you to kind of build triggers on top of Cosmos DB. Not that I would advise building triggers, but this would allow you to move data back and forth between different places or manipulate entries in your Cosmos DB using a function. You can also fire on service bus queues and service bus topics. So these are all laid out really nicely inside of Azure Functions. And it's tightly integrated with the .NET runtime and with the code that you write. So if you think of something like Lambda, if you want to receive a message from SQS, the message that comes in is a pretty raw SQS message. In Azure Functions, instead of getting back in sort of that message with all the headers and all of that stuff that you have to parse out and then do a bunch of JSON manipulation on, Azure Functions will just give you the message and it will strongly type it for you, so to do all that deserialization stuff for you. So it makes it really quick and easy to use Azure Functions just by using these tie-in points here, these integrations. On the other side, there are these things called output bindings. Sorry, this is probably pretty small on most people's screens, but I'll just run you through them real quickly. Just to give you an idea that there are a lot of output bindings here. So if you have something inside of your function and you want to send, say, a Twilio message, like a text message, as part of your function, you don't have to create a new Twilio client and tie all of that in, give it credentials and all that sort of stuff. You can just set out an output binding on your function, which will allow you to call directly into Twilio very quickly and easily. And send the message directly out. And this integrates with a bunch of other services too, so you can send messages out over Service Bus or send emails out using SendGrid. There's integration with the Microsoft Graph and with the various Office APIs, so you can drive things like anytime somebody sends you an email, you can do something with that email based on the Microsoft Graph event inside of your function. And of course, things like table storage, event grid, event hubs, all of these things that you can send. Signal R is a particularly interesting one. So if you have something inside of your function that happens and you want to update a bunch of clients based on Signal R, you can tie into the Signal R service inside of Azure and use this to send out messages. So this is something that I've been really enthusiastic about over the last couple of years, is that because of this tie-in now with Signal R service, it means you can build an entirely serverless event-driven application in the cloud on Azure without having to provision any server resources whatsoever. So you can build chat clients and really high throughput applications that scale up nicely using functions and the Signal R process. If you are building a web API based on this, there's some great integration with web security. So you can stand up anonymous functions. So these would just be unkeyed functions that run for anybody to use. So if you had an open API that people could call into, then this would be a great way to use that. You can use function level authentication. So this requires that keys are passed back and forth between the caller and your function. You can also tie into Azure Active Directory using JWT. So the idea here is that if you had a single page application written in something like Vue or React, then you could authenticate people through the serverless endpoints of Azure Active Directory. So you don't have to set any of that up yourself. Azure Active Directory handles all the scaling of that. They will authenticate with that, get back a JWT. This JWT is then passed to your function calls against Azure Functions, and Azure Functions will decode and validate that JWT against Azure Active Directory for you. I should warn you that this is a little bit tricky to get set up. I spent 2 weeks, maybe a year and a half ago, trying to figure out how to get this to work properly. And although I eventually got there, it was one of the most frustrating things I have ever had to do. So you can build applications entirely on top of Azure Functions. You can respond to events in Azure. You can respond to events in applications. You can use this to build a serverless backend. These are really good for processing large amounts of data in parallel. But like I mentioned before, one of the places where this falls down is if you have a long-running process or a complicated workflow. Azure Functions out of the box might not be what you need. You might want to look at durable functions, which we'll talk about in a second. There are a bunch of different ways of hosting your Azure Functions. So you can host them using the serverless model, where your functions will scale up and scale down dynamically based on the number of requests they receive. You pay per execution for this. If you already have a website or an application running on Azure App Services, you can tie into the existing Azure App Services and build your functions on top of that, so it uses the resources that your app service plan has. And then relatively recently, Azure Functions Premium was created. So this solves a lot of the problems of kind of the lower tiers of Azure Functions. You have VNet support, it eliminates cold starts, it removes that kind of time limitation on running a function. And these are built by reserved instances. So I see I have a question here, so let me take a look here. Right, so this is a good question here. So Scott's asking about Azure Functions scaling up and about backend resources that might not scale up quite so dynamically. So let's say you have an application here that receives a bunch of requests that come in. Azure Functions notices that you're receiving more requests, and it will scale up your application based on that. But if your application is accessing data inside of a database, it's not necessarily going to allow you to scale that database up. But there are fortunately hooks inside of Azure for scaling those systems up as well. So fairly recently, one of the new features inside of Azure SQL is that they have dynamic scaling for databases now. So you can set up a number of vCores that you want your database to scale to. And so you run it normally at like 1 vCore. But you say, if you need to scale up to 10 vCores, and again, there's monitoring inside of that, which will notice that response times are increasing, and it will scale up the database based on that added load. And that's possible with things like Cosmos DB as well. So a lot of these resources will scale as well with your application, and that's ideal. It's the ideal scenario. If you find yourself running into situations where you're using a resource behind the scenes that cannot scale up, so perhaps you're calling a third-party API that just is getting hammered and just can't scale up, then you need to start looking at how you can kind of pull back on your Azure Functions. So you can limit the number of parallel instances of Azure Functions, and then you can also look at doing things like scaling them down, queuing requests, those sorts of things. Just the normal processes you would do around really high throughput situations. One of the things that you can actually do to help with that is to use this technology called durable functions. So durable functions is a layer on top of Azure Functions that allows you to build workflows on top of Azure Functions. So this is one of the places that I said that functions kind of fall down a little bit. Is that if you need to build complex orchestrations, it's difficult to do inside of Azure Functions. Well, durable functions really helps with that. So if you have ever used something like NService Bus, this is kind of a competitor to NService Bus, give or take. I have a blog post out there talking about the advantages and disadvantages of durable functions versus NService Bus. But in my mind, they're definitely competitors to one another. So durable functions, it manages states, retries, delegation. It provides for reliable execution on top of your functions. and allows you to build out these sort of workflows. So the sort of workflows that I'm talking about are things that you have like chains of execution inside of your code base. So it could be that you're calling out to a third-party API, and then you take that response and you do something with it, and you call out to another API, and then you do something with that response, and then you return some information to a caller. So being able to chain those functions together is a really nice approach. So you can do things like if you had one of your integrations might be, say, billing somebody, and let's say that your billing service, which is a middle box here for argument's sake, has fallen down for whatever reason. We don't want to fail the entire process here. So what we can do is we can set up durable functions around it, and we can carve off what would have been originally like one function call into a bunch of function calls. We can scale those bits independently. And then we know that if something has gone down in the middle, we can maybe still complete, we can still tell the user that they have successfully purchased their item. And then once that billing service is back up again, we can process the rest of those requests. So this is a standard scenario that you see inside of durable functions. You might want to call one thing right after the other, and you can do that really nicely with durable functions. It provides also for retry patterns. So retries, a super important pattern in any sort of distributed computing. Very frequently, services are down. Could just be that the network has failed, that they're transient failures. So you might want to retry them again. So this is great for those sorts of scenarios. This is very common inside of any sort of messaging system, that you'll have these retries where you just wait 20 seconds and then try again, and then wait 40 seconds and try again, doing this sort of like exponential back off. Fan out is another really common pattern the durable functions enable. So if you have something where you need to split it up and then do a bunch of requests simultaneously, the same sorts of things, and then fan back in again at the end, this is a really useful pattern. So if you have some sort of computation, a really complicated sort of computation that you want to fan out, and it's nicely parallelizable, you can bring the computation in, you can fan out to 3 or 4 or 10,000 instances of functions, and then gather those results at the end back in and provide an aggregated result back to your end user. So places that I have used this in the past might be kind of like symmetrical things where I need to run a bunch of processes simultaneously. So I'm thinking of, I have a scenario where I make a call out to an API and it returns a list of things, and then I need to run the same process on each one of those. So I might scale that out by running each one of those inside of an independent function. And then there's sort of like the asymmetrical approach where you have 3 different things that you need to do, all of which are different, but you need the answers back together at the end. Then you can build out this orchestration in the same way. Kind of a variation on fan out is instead of awaiting everything coming back, you just await the first one of these things coming back. So if you were building maybe a stock picker service, or I have a great example where I'm decoding some VIN numbers from cars, and there's a couple of different services out there that can provide me that information, then I might call all 3 of those services simultaneously, and whichever one comes back the fastest, I'm going to use that response, and I'll just cancel the other 2. Timeouts are also a really useful pattern in any sort of distributed system. So there's sort of 2 ways you can use timeouts. So one of them is sort of like a business process where maybe people add things to their cart, and then if they don't check out in their cart, maybe you send them an email in a week's time to remind them that they have items in their cart and that you can offer them a discount if they go back and finish their transaction. So that's one sort of timeout. And then you could also do timeouts around, you could call a third-party service, and if it doesn't respond in a certain period of time, then you can time out and you can run some sort of compensating action to handle not having that data. So all of these patterns, of course, can be kind of coupled together. So you can run a timeout pattern in conjunction with a retry pattern, and then you get a really robust sort of workflow based on that. Another place is some sort of external interaction you can have. So durable functions provide an endpoint that you can call into to update a workflow. So if you have some sort of external user interaction, typical example of this would be some sort of an approval workflow. So you kick off some sort of deployment, and then you need to wait for somebody to approve that. So the function kind of sits in that state in the middle there and waits for input to come back into it. And once somebody has passed input back into it, then it continues on with its processing. So this is a really nice pattern to do inside of Azure Functions. And I know that I had mentioned before that you get billed sort of by the second that the function is running. If you have a pattern like this and you're using durable functions, this function kind of goes to sleep and you don't get billed for the time that it is just sleeping. You only get billed for time when the function is actually running. So if you have a workflow like this and you need to put it to sleep for a couple of days, you're not going to be billed for that time that the function is sleeping. You'll only be billed once it's woken up and the process continues. And then probably the final sort of thing that we take a look at here is sub-orchestration. So you can build all of these big orchestrations, and then within those you can have smaller processes that run just to do parts of that larger orchestration. So I have a great service out there where we go out to an API and we gather a bunch of data from it. And then we do a bunch of things with all of that data. So we pull back a couple of big sets of data, and then we run each one of those in a sub-orchestration to do its processing. And then once all of those are complete, then we mark the entire orchestration as complete. All right. So we're going to take a look now at what it looks like to kind of leverage the production debugger for Azure Functions. So let's drop down and I'll show you, we'll drop into Visual Studio here and we'll take a look at how to build up some Azure Functions here. Okay, so I have here Visual Studio 2019. I'm going to create a new project here just to show you what Azure Functions looks like. So we'll use Azure Functions template here. As soon as my computer catches up. Oh, just in time. There we go. I have no idea what got created there. I think Visual Studio might have just crashed. Let's try that new project thing again here. Working a little bit better now. So I'll just create kind of a standard function app here, and you can take a look at what this looks like. So by default, in the latest version of Visual Studio, this runs on .NET Core 3. It's actually .NET Core 3.1 under the covers. But this gives you an idea of what sort of triggers you can build right out of the box. So these are kind of templates for a bunch of different kinds of triggers. So timer triggers, you can see here, they've got some scheduling associated with them, service bus, queues and topics, queue triggers, all of these things. We're going to jump on an HTTP trigger here. And we're going to just leave this as like an anonymous function here. And in the backend, this stuff uses a storage system to set up durable functions and those sorts of things. So we do need to have something, but we have a storage emulator running here, hopefully. So we'll just go and create this. And as you can see, it stands up a nice little function for you here that gives you an idea of how to build out one of these Azure functions. So you can name your function just with an annotation here. And when the function's runtime starts up, it just kind of goes through your code base and looks for anything that has a function annotation to it. The input here, we bind this thing using this little annotation here to say this is an HTTP trigger. The authorization level is anonymous. We support for this one the get and post verbs, and right now we have no root assigned to this. And we're going to get an HTTP request. There is built-in logging inside of Azure Functions. So this will use sort of the same log streams that you would have inside of an ASP.NET Core application. So you can log out to application insights or Serilog or anything like that you want here. And we have access here to the HTTP trigger information here. So we're going to get back the name, And then we're going to read our request body, deserialize that, check if that has a name, and then we'll print out a response here. So I'm going to actually switch over to one of these functions that I already have built, so we don't spend a bunch of time figuring out how to do this. So what I have here is a function that decodes VIN numbers. So if you're not familiar with a VIN number, it is a 17-digit number that exists on every vehicle that's produced in the United States, or every vehicle that is sold in the United States, possibly everywhere in the world now. And it uniquely identifies the vehicle. So it encodes information within it, like the make, the model, the year, where it was manufactured, sometimes information about what trim level the vehicle has, those sorts of things. And there is a handy service here, which is provided by the US National Health and Transportation Safety Administration to decode VIN numbers. So we're going to take our VIN number here and we're going to decode it and get a little bit of information back. The kind of business idea around this is that we are working for a company that offers a service where they take your vehicle and they put it in a box and pack that box full of those really annoying styrofoam pellets so you can ship your vehicle safely. So one of the things that they need to know is sort of like the volume of your vehicle. So if you think about the height and the width of your vehicle, then they need to be able to like multiply that together to get kind of like how many square centimeters, so how many cubic centimeters your vehicle takes up. So this service is going to do that for us. So given that VIN number, we're going to decode that information. Now, that information coming back from this is great, but it doesn't contain the size of the vehicle. So we're going to take that information, we're going to pass it to a second API, also provided by NHTSA. And we're going to decode from that the width, length, and height of the vehicle based on the make, model, and year of your vehicle. So this is a fairly simple sort of service, and we'll just try running that locally first. So this is going to start up the Azure Functions runtime. Now, the interesting thing about the Azure Functions runtime here is that the runtime that you get on your computer is actually the same runtime that you get running in the cloud. So the performance and the way it works is very similar. It allows you to have a really good experience debugging against this. Be pretty confident that if it works locally, it's going to work remotely as well. So I have here Postman, which allows me to make calls against APIs locally. And I'm going to try and decode a VIN number here. So I have this VIN number here, and it's going to hit that locally, and I'm hoping this is going to work. I had some problems just before this demo that the remote service was down. Fortunately, it's back up again now. So given this VIN number here, and I think this is a Acura Legend VIN number, we're given back the volume of that vehicle. So this is working well. Our test case works nicely. Let's go and deploy this up to the cloud. So I'm going to go and publish this service out to the cloud. How to do that. So I'm going to publish this out to a new Azure function. And I'm going to deploy mine on an Azure App Service plan here. And I'm going to create a new one for that. So you can use a consumption plan for this or an App Service plan. I'm going to use an App Service plan for this. And I'll run it through something like this. Create a new storage account for it. And it's going to go and run out there in the cloud. So the question was, does the debugging work on both consumption and app service plans? Omar can correct me on this, but I think it only runs on the app service plans currently.
That's correct, yes. But
Okay,
we are looking into ways of enabling it also for consumption plan.
great. So I'm going to let this run here, and we'll see if I can jump over into Azure itself and check out what this looks like. Portal.azure.com. Sure I'm in the right account here. All right, let's take a look at functions here. All right, so that is busy over here. It looks like it might have completed. So I can hit publish here now. Publish my application out. And then I'm going to integrate this with the Ozcode Production Debugger. So there's a variety of different ways of running this Ozcode Production Debugger. I'm going to go and stand up a brand new application here. So this is using the hosted model for deploying the production debugger. If you have information on your system that is private or you need to keep inside of your firewall, you can set up the production debugger inside of your firewall and get all the same sort of functionality as we get here. So this is really handy in that there's some good installation instructions here. I think I'm running on Azure, I'm running on Windows, and I'm running inside of Azure Functions right now. So this gives me a great idea of how to get started with this. So I need to drop over to the platform features and add the site extension for this. So let's go and refresh this. I think it was this one here, function debugging. So platform features, site extensions. This is pretty quick to do here. So we'll just add, choose our extension. Really wish there was a search box in here, but there isn't. We can just quickly scroll down, element O, code, and we'll agree to all the legal terms here. And this is going to go and run the installation for us. So that is kind of half the battle of getting this thing set up. The other half is we just need to add a quick key into our Azure Functions instance. And that is this key here. So I will throw that on my clipboard. And then this is the name the key needs to take. So we'll copy that as well. And then over here, we can add a new app setting here. And I don't know if people have seen this before. This is like my discovery of the month, that if you press Windows V instead of Control V, it'll give you a history of your clipboard. This is made like way more productive in terms of being able to copy stuff off of Stack Overflow now. So we'll just save that, and that's going to restart the site. And assuming, so our extension was installed properly, so this looks like it's going to work for us. So let's try and run a request through here. So if we drop back to our function app here, we have this decode vin URL, and we'll just sneak in here and find out the key and all of that for this site. Eventually. All right, so this is positive. We can see now that we have this little check mark here that the agent is up, and we can start debugging our application now. So while this gets itself going in background here, let's get this function URL here. I'm going to copy this and head back over to my Postman collection here. And I'm going to go and just edit my environment here so that I have the right URL. This is now this URL. I'm just going to steal this code as well. So we should just better drop our environment over here to remote, update our secret code here, and hit send, and hopefully this will give us back the same information that we had before. The first call to functions tends to be a little bit slow as it warms up, but there we go, we got this number back. And if you drop over the production debugger, you'll see that nothing has changed here because there have not been any errors yet in our application, which is great. So we're really confident in our application, everything's working great. We can go out for lunch now. But while we're out for lunch, looks like somebody's going to pass in a different VIN number here. So they're going to send a request over here, and they got a 500 error back. So if we drop back to the production debugger here, hit refresh, we can see that there has been an error while executing the decode VIN. Now, the first time through, this doesn't give you a lot of information about it. So the production debugger is super efficient in that it doesn't make really any changes to your application until the first time an error is hit. So because we've hit this error once, we can see the mode here has changed to capturing. So what this means is that the Ozcode Production Debugger is instrumenting our code. So the next time an error occurs, we should get a lot more interesting information back from it. So let's go and hit it again in Postman here. So everything looks about the same for the user. But then if we come back over here and refresh, we can see that we've hit this exception now again. So we can drop in and hit debug on this exception. Now this is pretty cool because this gives us much more information and much more power than we would have got from basically any other debugging tool out there. So right here, you can see the same sort of annotations that you would get running Ozcode inside of Visual Studio, but you get it inside of your browser here. So we can take a look and see what went wrong. So we know exactly what line number there was an error on. We can even see exactly where in that call there was an error. So there's an invalid operation exception occurred when we called first on the results of our decoded vehicle. So it looks like our first call probably worked out okay. We got information back from it, but something happened on the second call here. So this means that we can go and take a look at what the values were that came in here. So you can see that it's kind of highlighted here. So I can see this is the VIN number that came in. The URL that was generated is this one right here. So I mean, that looks okay to me. We know that first call worked out all right. We keep going down, we can see that it generated another URL down here with the make model in it. So it looks like this one decoded to a 2008 Tesla Roadster. So let's go and copy this URL and plop that into our browser and see what we get back from it. Maybe that'll give us some hint as to what's going wrong inside of our function. Okay, that's interesting. So it looks like what we got back here doesn't actually have the information in it that we need. Like, we're looking for the size of the vehicle here, and that isn't here on this particular vehicle. So like if we change this to 2019 Model 3 maybe, I'm just guessing here what this is called. 3 maybe. We get back a lot better information from that one. So now that gives us a really good idea of what we need to do to go and fix this. So we aren't going to be able to call that second function as easily now in this scenario. So what we're going to have to do is we're going to have to go back into our application, probably put some checks and balances in to make sure that this error doesn't occur. So I guess we'll have to do some checks in here to fix this out. But we know exactly what the error is. We can go and we can run it immediately. We can do all the fixes. And now that we know what this problem is, we can just add some comments here. So we can say things like, looks like the in decoding work, but getting back into so good. All right. So this is added to the collaboration so that the next people who come in and look at this, if we have a larger team working on this product, will know that we've already started an investigation on this. this allows us to set up a whole conversation around this particular problem. And then once we feel like, hey, we've got this thing figured out, we're going to deploy this in our next release, then we can drop back over here and we can mark this one as resolved. So we understand this problem, we're going to fix it, it's no problem. So another question here from Scott, you've demonstrated debugging for an HTTP trigger. Does the debugger work for activity functions and sub-orchestrations and durable orchestrations as well? Yes, it works for any sort of managed code, basically. So this will have no problem doing that. It isn't necessarily just because it's an HTTP trigger. This could have been any other kind of trigger. It could be anything else that was happening, a sub-orchestration, orchestration, anything like that. So if you look at the annotations that we get in here, the instrumentation, it doesn't care that it happens to be an HTTP trigger. It just monitors for when an exception occurs. And when the exception occurs, it instruments the code, gathers all this information, and then it actually removes the instrumentation so that the next time this function is called, it's not slowing down your application at all with added instrumentation. So this is just like a point in time that we get to see some really good information back from this application. So this is a super handy tool. If you can imagine what it would be like deploying this on a large application that had hundreds or thousands of endpoints, this gives you some great information back. You'll be able to quickly find bugs, and you'll be able to drill into the actual problems right away. I mean, in my mind, this is almost better than running it inside of Visual Studio, because Visual Studio would just tell me the line number, would tell me that an exception had occurred on line number 11. This tells me exactly the operation that we had. We'll only be able to debug the code on the second occurrence of an exception. In other words, if an exception occurs only one time, we'll be able to debug it still. Unfortunately, no, you won't be able to debug it because we don't want to instrument the entire application every time. So we're relying on an exception occurring kind of more than once. You do get some information back if the exception occurs only once, but you don't get this sort of like rich view of the information until the second time through. Okay, so I think that kind of finishes up everything that I wanted to talk about. I'm very excited about the Ozcode Production Debugger. I think it's going to be pretty exciting for people out there, especially people who are running kind of difficult to debug applications where it's hard to get the right logging in place. You saw how easy it was to instrument this application. Like, I literally added a key and a site extension. We were up and running in less than 30 seconds. And then, of course, this works on a variety of different platforms as well. So it doesn't have to be an Azure Function. We can run against any .NET code, and it even works against like desktop code. So if you have a thick client application that you're deploying, this will give you that same sort of view into it. All right.
So Scott asks, if I have the Ozcode extension for Visual Studio, is this included in that subscription? So we haven't announced pricing or the subscription model for bundling yet, and you can check our website for updates on that. The second question here from Simeon Brett. Are there any security concerns deploying this in a production environment? So we won't go into this because it's out of the scope for this webinar, but the Ozcode Production Debugger treats security as a first-class feature, and that there are several facets to that. One being the fact that you can deploy the Ozcode Production Debugger on-premise, and on-premise may mean on your the server that you have in your basement tucked away, or it might be that you're deploying the Ozcode Production Debugger on the same Azure or AWS subscription as your production code, and in that regard you have data sovereignty. You control, you own the information, and you can even perform IP whitelisting to control at the IP level who has access to your self-hosted production debugger server. There's also quite an extravagant support for redaction of sensitive information and personally identifiable information, but that is out of the scope for this webinar and will be part of a different webinar. Thank you for your question.
That's a good question. That question feels so good that I'm suspicious that you had it planted.
Almost.
All right, great. So I think we're going to make recordings of this session available at some point in the near future. So if you're interested in coming back and seeing parts of it or sending it to colleagues, we should have an option for you there.
Absolutely. That will be up on our website and emailed to you guys in just a few days.
All right, great. Well, if there's nothing else, then we will shut it down, and we'll see everybody hopefully in the near future at another one of these.
Absolutely. Thank you, everyone. Have a great day.
Thank you.